Hi, friends. Thanks for joining us. Thank you for being here with At Home with APS. I'm Miss Garcia.
And I'm Mr. Abeda.
We are so excited for you to be here with us today. Let's just jump right in and let's review the essential question, and then we're going to dive deep into our imagination and engineering today. So our essential question, how can I understand and design tasks for a robot hero? Ooh, a robot hero. I'm so excited to know what that is all about.
I am so excited for us to start talking about planning our robot hero and look at some robots as examples so we can learn how to build and design robots for the future to solve problems. But first, Ms. Garcia, I am so excited to be on stage with you here.
Me too, I'm so
My sons
excited.
and I have been watching APS at home, and Enzo wants to meet you so much, and he wants to see Mr. R and Miss Martindale.
Aw.
He's so excited. So it's
Hi,
so
Enzo.
cool to be on stage with you. Thank you for having me.
Yeah. So let's go over into, well, what's engineering the future?
Thank you for asking.
What is that?
So I work for a unique department at APS. It's called Engineering the Future. And at Engineering the Future, we do some very special things. We work with a K through 12 pathway, meaning we work with kindergarten through 12th graders. We work at 3 schools, Mission Avenue Elementary, where I know Miss Garcia from, Garfield STEM Middle School, and Valley High School. And what we do at those schools is we help the teachers and the students learn about technology, about robotics, about science. We help them think about creative ways to come up with solving problems. We use some very specific learning tools with our teachers and our students at these schools. One of them is called the design process. The design process is back here on our poster. The design process is a set of steps that engineers, scientists use to create, plan, and make. We also use something called the learning habits of mind.
My favorite.
The learning habits of mind are so fun. On our poster, we have curiosity, open-mindedness, and resourcefulness are some of the learning habits of mind, but we also work with the engineering habits of mind. And those are a little bit more specific, but they're very helpful when we plan and work with robots and science projects. So improving, visualizing, and problem solving. And that's one of the things that we're really going to work on today is solving problems. So at the schools, one of the things that we've been working on is robots. Can you tell me a little bit about what you've done with robots?
Okay, so I'm way super excited to just dive deep into this because, like Mr. Abeda said, we use the design process, we also use our habits of mind, and we use that in our classroom every day. The neat thing is as he was saying, how do I use robots? Well, we were working with our students before all this happened, and we were going to have this huge showcase. And in this showcase, we were going to have all 3 schools put all our ideas, all our designs, all our robots, all of our neat things together. And so 4th grade, our class, we were designing robots, and we were coding them. We had prototypes. We were designing them to potentially help humans. And what they were going to do is there's hazardous jobs that humans do. And so we were thinking...
Hazardous, like for example, what would you mean?
There's firefighters. We were trying to think of ways where the firefighters weren't the first ones to go into the fires. Like how could we have
Wait, you mean
sensors?
a robot would go in before a firefighter?
We would...
But why? Wouldn't the robot burn?
No, the kiddos were designing material, figuring out what material would sustain in a fire, how could it help the firefighters so that they weren't going in first, what ideas, they were coming up with ideas of, how could they help?
How inventive.
Yes, but not just firefighters, all sorts of things, like maybe construction workers, maybe those who work underground in tunnels, maybe oil fields, all kinds of different things.
Oh, you mean hazardous jobs?
Yes.
Oh.
Like dangerous, like where someone could get hurt.
Well, I'm very glad that you brought that up because I'd like to share with everybody a story that I just heard on the radio the other day, and it's about a very specific robot. And this robot is a robot hero. And that's the reason why when I heard the story about the robot hero, I thought about the other heroes in this crisis. Oh, yes, we have a question.
I have a question. So you said you heard a story on the radio and you
Yes.
would share it with us.
So
Is it a credible source?
That's a very good question.
I want to know. How do you
Yes.
know?
So I listen a lot to the NPR News on the radio, which is a news program. And I heard this story while I was driving. And I went home, once I got home, and I looked it up on the website. I went to the NPR News website, and I
Practicing etiquette
reread the
here.
story. And I went all the way to the bottom of the article, and I looked at some of the sources and where else the story appeared. And it appeared in multiple places, and it was the same story.
If I had a gold star, I'd give it to you.
Well, I would love to read the story to you and talk
Sure.
about Spot. Okay. So this is a news article, and here our picture is of Spot. So please, if you could take a look at Spot. Brigham and Women's Hospital in Boston has been testing a new piece of hardware to help them treat coronavirus cases, a robot called Spot. Last week, the hospital began using the robot in interviewing patients suspected of having less serious cases of COVID-19. It's only been deployed a handful of times so far, but according to Peter Chai, an emergency medical physician at Brigham and Women's, the hope is that using Spot could limit staff exposure to COVID-19. It also eliminates PPE, said Chai in an interview. Spot doesn't need to wear a mask or gown. Spot was developed by robotics firm Boston Dynamics and has been on the market for some time. The robot's distinct four-legged design helps it navigate terrain where humans and other robots may have difficulty going, says Michael Perry, Vice President for Business Development. Part of the benefit of legged mobility is going to spaces that wheeled robots and drones cannot go, Perry told NPR. Although Spot was not developed specifically for medical purposes, the firm says that once the pandemic hit, hospitals began asking if our robots could help minimize their staff's exposure. One of the hospitals that we spoke to shared that within a week, a sixth of their staff had contracted COVID-19 and that they were looking into using robots to take more of their staff out of range of the novel virus. Boston Dynamics said in a statement. Boston Dynamics then consulted with MIT and Brigham and Women's, outfitting Spot with an iPad and radio so a medical technician could interface with patients in the triage tent in the hospital, and others can use it for potential COVID-19 patients. So far, Spot has been mainly used to interview patients, but Perry adds the next plan is to have the robot start taking vital signs of new patients, which he says could happen as soon as next week.
Wow. That is such an interesting article.
Doesn't he sound like a neat robot?
Yeah. I wish I could see the real Spot. We don't have Spot here, but would you maybe share what?
Well, let's look at how Spot is made, because he's a very specific type of robot, and he has some characteristics that we're going to use as an example to understand other robots.
Oh, wow.
So first of all, we could see here, Spot has an iPad on his head.
Wow.
That's very interesting. So, but if we looked at the iPad, and here's an iPad, my iPad, we could see that Spot is probably about this tall.
Wow.
And that looks just like about the size of a dog.
Maybe that's why they call him Spot.
I know. Well, did you notice how he walks?
Yeah.
He has 4 legs.
Just like a dog.
Just like a dog.
Yeah.
So they also mentioned that these legs, they give Spot movement, but they let him go maybe into a place where a robot that has wheels could not go. That might be into a place that's dangerous. For example, maybe there's dangerous chemicals on the floor.
Yeah.
Well, that is very hazardous to us humans, but for a robot that's made of metal, it could definitely walk into some place that might be hazardous and not get sick, or let other people get sick.
And I like how you said he does not have wheels. And so since he doesn't have wheels, then he won't get stuck in anything like you said. So he could walk over maybe debris or something that's fallen.
That's right. And Spot can even walk upstairs. Something that a wheeled robot would have problems going up a flight of stairs.
I'd really like to see that, yeah.
The other parts of Spot that I'd like for us to look at is right here underneath the iPad, above his yellow body. And those are his sensors. So sensor is one of our vocabulary words that we're going to go over today. So when we talk about the word sensor, what does the first thing that comes to mind?
What does it sense? What does it see, maybe?
Yes, well, what are human senses?
We have our eyes.
Yes, visual eye sensors.
We can hear with our ears.
Yes, audible sound sensors.
We can smell with our noses.
Yes, yes, yes.
We can,
Odor.
not right now, but we can touch things.
Yes, we have tactical sensors on all our nerves. Well, but where do all these sensors go to? Yes, the brain.
Yes.
Excellent. Kind of like a computer or a controller. And we're going to talk about those when we look at robots a little bit more.
Yes.
Well, so good. So Spot has some eyes. They're right in there, and they look like cameras. And they sense light. And some sensors can sense temperature.
Wow.
Some sensors can sense sound. And Spot also has in this array of sensors a GPS.
Wow.
You know what a GPS is?
GPS. I've heard that word before. And I know that there's one in my car. So is
Yes.
it kind of like helping me get somewhere?
Yes.
There you go.
A GPS is a computer that uses the Global Positioning System satellites to help us
Big words.
know where we are on the Earth.
Yes.
Anywhere on the Earth, if you have a GPS, and yes, a GPS is in your phone, some GPSs are in cars, and some GPSs can be built into robots, so the robot can know how it's moving, if it's moving forward or backwards, where it is.
I like that because if it's going somewhere, like let's say a fire, we need to pinpoint where it is.
It needs to go to the right place.
Yeah, so having a GPS would work perfect.
So let's take a look at what else makes up Spot. Oh, his body. The body on Spot is the place where we have tools. Okay, so he has a tool, and that is something that holds the iPad and lets the iPad have power. That's very important for Spot. That's one of his biggest tools because that tool lets the doctor talk to the patients without being in the room. It lets the doctor see the patients from the camera, and it lets them hear them what problems they might be having. And all of this is being done while the doctor or the nurse or the medical professional is in a different place than the infected person, so that we're lessening the chance of people getting infected by a virus.
I have a quick question.
Yes.
So I know if my students were here, or I'm pretty sure maybe some of our Mission Avenue students out there would ask, they'd be wondering, how does it power up? Do you think you mentioned tools? Does it have maybe a power pack? Does it have a charging system? Like, how do we keep that iPad from shutting down?
Okay.
And I know those are questions that they would ask because those were questions they asked me.
Those are very good questions because, yes, things have to have power. Specifically, robots have to have power. And that's one of the characteristics that we are also going to be talking about today.
Yay.
Is
so we're
the
on
power,
the right pathway.
The power that the robot uses to move, to sense, and to use its tools.
Oh, good.
So if we take a look back at Spot, he doesn't have a power cord. Most things like our computers or even our refrigerator, our toaster, have a power cord that has to plug into the wall. Well, that might be a problem for a robot that needs to move around into very specific places. So Spot has a rechargeable battery.
That is super cool.
Do you know other things that might have rechargeable batteries?
My cell phone.
Yes, a
I always
cell
have
phone.
it.
What about an electric car?
Wow.
Electric
I didn't
cars
think
have
about that.
big rechargeable batteries that have to be plugged in, but once they're charged, they don't have to be plugged into the wall to receive electricity.
Oh, wow.
Okay, so Spot receives electricity from his battery. That lets him move around. So these are some of the characteristics of robots. And I brought some robots for us to look at today
Super
so that
cool.
we can understand how they're made and what purposes or problems they might be helping solve.
Perfect. So friends at home, before we get to see the cool stuff that Mr. Abeda brought, what I'd like for you to do now is make sure you have a piece of paper, a pencil, and remember we could do some 2-column notes. And I'm just going to reference real quick back here. You'll fold your paper in half. You have vocabulary on one side, meaning on the other. And I'm just going to read off what our different vocabulary words are. So if you hear them, you can write what the meaning is, and you can keep it for later for your notes. And then also we're going to review with you what they mean, just to double check that we are all on the same page. Our first word is design process, prototype, sensor, and I know Mr. Abeda was already talking about a sensor, criteria, engineer, programming, and energy source. We were kind of talking about an energy source. So make sure you have your notes and they're ongoing and we're working together, but then we will work with you to make sure that we all have the same meanings together. So
Yes.
let's learn about what you brought.
Now that we're getting started, let me give you a chance to get your materials ready that you would need to use today. And it's not very many. It could be something very simple, like Ms. Garcia said, a notebook.
Ooh.
This is my engineering notebook. And I will be referring to this later, but this is where I keep notes, draw pictures, write down ideas, take records, and document things that I might be working on. So if you have a notebook, that would be great. But if you have paper, fold it in half like we're doing for our vocabulary words, and we could get started. The only other things that you could use today, if you would like, would be some colored paper, some colored construction paper. It's not necessary, but it could help you organize your thoughts today. So I have some colored construction paper that we're going to use, just a few colors. But if you don't have construction paper, you can use crayons to color today. You could also use markers or pens. So it's going to be up to you. You don't have to have colored paper, but it might help you in your design today. Scissors. Scissors would be the other thing, tape and or glue. But you might not need that at all. If you're just doing everything on a piece of paper and drawing, that would totally be fine.
Yeah. Did you want to share with us what you had on the table? Show
Yes.
and tell some of your fun stuff, because I can't stop staring at that.
Okay. So one of the things that we've helped Engineering the Future, my department at APS, has helped our schools with is acquiring technology, specifically robots, and helping teachers teach kids how to build them, program them, and work with them. One of the robots that we use at our middle school and our high school is this. This is called a VEX robot. And the VEX robot, in some ways, looks like Spot because it's yellow and it's black, and it has a sensor on top here. So let's start looking at the characteristics of robots that I mentioned, because I'll use this VEX robot as an example. So the first thing that a robot needs to have is a body. Just like a human, a body is where our arms are attached to, our head's attached to. And a lot of times it is the central part of a robot. Not every robot has a body like a human, though. Some robots just look just like an arm. There's a robot that manufactures cars that just goes up and down like this, and it looks like a big arm that's grabbing things.
Wow.
So that's its body. But for our VEX robot, the body is made up of this yellow main part here that holds the sensors. So I have one sensor on the VEX right now, and that is a visual sensor or an eye sensor.
Oh, neat.
So this can sense when a light's turned on or off, or how bright the light is. And this sensor is attached to the middle part of my VEX robot, which is called the controller. The controller is also like a brain.
Okay.
So if you notice, I actually have these wires that are connecting. This wire connects the sensor to the main part of the robot, the inputs here. So the other connectors I have are for the wheels. So this cord goes all the way down to the bottom, and it connects to this right here, and that's the motor that turns this wheel. So this robot has movement, and it has movement from its wheels. That's a second characteristic of robots. They have a body, they can move,
Oh, wow.
they have a controller or a brain. They also have sensors, and the last characteristic that we haven't talked about yet, or I've shown you, is the battery. So here is
There's
its
its
power
power
source. And let me turn it on really quick. So I just checked the little button here to see how much power it has, and it's all fully charged up. And the battery has a cord that connects to the brain. So this robot can be programmed to move by itself. So let me show you really quick and make sure it doesn't fall off the table.
Uh-oh.
So let's see if I can get this robot to move here. So in the brain has another connector that connects to the computer.
Okay.
And you could code or program. Have you heard of coding before?
I have, and I know all of our kiddos at Mission, at Garfield, and at Valley, they code all the time. But just for our friends who might not code, could we explain a little bit more how coding works or what it takes to code a robot?
Well, sure. There's actually quite a few types of coding now. Coding is like a language that machines or computers can understand. And it gives very specific directions to the machines to use. At Mission, with your students, we do a lot of what's called block coding.
Yes.
We do that on iPads and computers, and we take shapes and we put them together, and it helps the robot know how to move. For example, one code would be a movement block, and I forget what color, I think it's green.
The colors we use are green, blue.
The movement block in coding is green, and the student enters into the block how many times the wheel should move. So it'd say, move the wheel 5, and then when the robot gets the code, it will move forward 5. So coding is a way to write directions. It has very specific vocabulary words too, and what we call syntax, which is almost like grammar.
Yes.
So we teach coding so that we could talk, so that we can give robots instructions. Some of our students at the high school at Valley program this robot to move forward, turn around, and move back. So we're going to let him do that, or actually, we're going to let the robot do that. I don't know if it's a boy robot or a girl robot. I think it's just a robot.
Whatever we want it to be.
Okay, so here we go. I'm going to hit run. Oh, let's see what he goes. So he's turning. We're going to make sure he doesn't fall off the table.
And did you code it to do that specifically? That's the direction you gave it, was to do a full turn?
The code was to turn around, and let's see, it got stuck in the middle of its code. It might be a bug. So let's get it started again. Let's see. Oh, here it goes.
There you go.
Make sure it doesn't fall off the table. So it's going, and it's supposed to go forward here, but I think there might be a problem with the coding.
That's okay, and guess what, friends? That's how technology works, and that's how the design process works. We build things, we design things, and then we find ways to improve them. So if something happens or we find a bug, that's perfect because we're actually learning when something like that happens. And so from there, we ask some questions, and then let's improve on what it is, and you figured out that there's a bug, and then maybe you can bypass that.
You know, that is one of the hardest parts about coding is when it doesn't work. And it doesn't work quite often.
Yeah.
So what we do in coding and what we tell the students a lot is it's great to fail because that first attempt is so important. It gives you all kinds of ideas on what to do next.
Exactly.
And that's one of the reasons that I have my, where'd my engineering notebook go?
I borrowed
that's
it.
That's why I have my
right
engineering notebook. Because when I make codes, I'll write in my notebook things that worked or didn't work. And that helps me to understand, maybe to develop a new plan next time so that the coding works correctly.
Yeah.
So engineering notebooks are very important to keep track so that you don't make the same mistake twice.
Exactly. And then going off of what Mr. Abeda just said, if you have your notebook and you're learning, and if we're looking over here at our habits of mind, you have to make sure you have some resilience and some problem solving and some problem finding. So he did some problem finding, and that's how he found that there was a bug.
Well, I'm going to turn off the Vex here. So we'll just turn off its power there and put them over here. And I want to show you another type of robot that we use at the schools, and that is a drone. So a lot of you at home have drones, and they might be this big, and they might be bigger or smaller. And you know, drones are being used quite often all around the world for all kinds of purposes. There's a lot of great photography shots that are done from drones, and they use them in the movies to get great car chase scenes.
Oh yeah, you said photography. I met this family online. We were using technology to communicate, and they were trying to figure out a way to take photos of their senior because a lot of the photo sessions had ended, and they used a drone to take the pictures for their senior, and they came out amazing. So I'm glad you mentioned that.
They are so neat, but they are a very specific type of robot. So let's look at this drone and the characteristics of robots to understand it. So what are some of the characteristics of robots, if you remember?
Let's see. Of this specific robot or
Any
robots?
robot. Because we were just talking about Spot and what he has.
So it looks
we're
like
talking about the Vex and what it has.
So maybe this one has legs.
It does have legs.
Yeah.
But do the legs help it move?
No, this one has like propellers on top.
Yeah, so
Those will help
movement.
it move,
So
yeah.
a robot needs to be able to move. That's what makes it different than just a machine or a computer. A computer doesn't move, but a robot can move in various ways. So this one actually flies
Oh,
like a bird.
so super cool.
And it has a camera. Oh, I'm sorry. It has a sensor.
So that's like its eye.
It's
That's
very
its
much
sensor,
like
yeah.
its eye. And then what other type of sensor do you think this might have that might keep it from flying upside down?
I don't know, Mr.
Well, we
Obeda.
were talking about a sensor in your car that keeps you from getting lost.
Oh, so the GPS.
A GPS.
There you go. Thank you for
Yes.
bringing me back.
This has a GPS built into the body. And that's how it knows how to come back to you. That's actually something that's very interesting
That
with
is
drones.
super cool.
Sometimes a drone can fly off too far and you lose control of it. Oh, we forgot to talk about the controller.
There you go. That's
So
where you're giving it
this
its command.
This is the drone's brain. Now, can the drone work by itself?
I think it needs to be given direction.
It does. And the way it's given direction is from the controller. So a human operates this drone. It doesn't operate by itself.
Very cool.
Okay, so let's see. What else? We have a controller that's like a brain. We have movement. This one flies like a bird or a helicopter.
The sensor.
We have sensors in here, the GPS, and then the camera sensor, the eye sensor to take pictures.
The controller. Did you say the controller?
We got the controller, the brain. The power source, the battery.
Why did I think of that?
This is just like our Vex robots and probably very much like Spot. It has a rechargeable battery that is plugged into the wall with electricity. So here's our cord that plugs into the wall. It plugs into the drone. We charge the battery just like we charge our phone or a computer. And when it's fully charged, it lights up in the screen and we know we're ready to fly. So the characteristics of the drone are very much just like the characteristics of our other robots. So I wanted to also refer back to Spot because he is such a neat robot, sort of like a hero, because he's helping save lives. Well, drones have also been used in the fight to help save lives from viruses
Like right now?
right now. So at some hospitals, they have outfitted the bottom of a drone with thermometers.
Wow.
So that they could take the temperature of people coming into a building from outside and above. So the drone flies up, it has a thermometer, sees people down there, takes their temperature, sends it back to the hospital,
Oh, wow.
and they could have a record.
So before they go in,
Before
or
they even
oh,
walk
wow.
into the hospital, the drone could help the doctors or the medical staff know what temperature the people are in.
Wow,
have.
okay.
So that's very cool.
It is very cool.
Okay, so let's take a look at how we're going to understand and build a robot hero, because that's really what I like to get to today.
So is that what our friends at home are going to do?
Yes. So if we refer back to our central question, how can I understand and design tasks for a robot hero? Design is probably the most important word in our essential question because that means we're going to come up with ideas and we're going to think about how a robot could be put together.
Okay.
Okay? Now, we have one more robot to share. I forgot to bring up the UV robot.
I didn't see one.
It's a picture.
Oh, okay.
Here's my picture of the UV robot.
UV. What does UV stand for?
That's a very good question. UV stands for ultraviolet.
Ah.
And UV light is a very powerful radiation that natural UV light comes from the sun, and it's what gives you a sunburn.
Ooh.
It could also give you cancer.
Ooh.
It's very dangerous to humans.
Yeah.
But to robots, it is not dangerous at all. Most robots are built out of metal,
Yeah.
plastic, silicon, something that's not affected or sunburned like our skin. But one of the great things about this UV light is that it also kills bacteria and viruses.
So I wonder how they're using this robot.
So this new robot is being used in hospitals, and it's very much like our Vex robot. It can drive. It drives into a hospital room that might have just had patients in it, and it does this when nobody else is in the room. That's very important.
Okay. So
because
nobody's in there, no humans.
first, the room might be dangerous.
Okay.
It might have virus or bacteria on surfaces within the hospital room.
Okay.
So before another patient or a doctor goes into the room, the robot drives into the room, nobody in it, and it turns on all of these UV lights that are on top of it. The UV light shines on all the surfaces, and it's so powerful, it kills the viruses and bacteria that are on those surfaces. So essentially, it disinfects or cleans the room without a person having to be in there that might get infected by what's on the floor or on the wall or in the air.
That is the neatest thing I've ever heard, because when my students were looking at jobs that were hazardous, someone did mention, like, what about people who have to clean certain areas that maybe have chemicals in there that are harmful to humans? Like, we brainstormed and we thought, and we didn't think of this at all. And look at here, we have this robot who goes in where it would be hazardous to you and to myself. And instead of us having to clean, this is disinfecting and getting all those harmful bacteria or anything that's in there out of the way before anybody else gets in the room. That's amazing.
So the UV robot has all our characteristics. It's
Yeah.
a remote control. That's its controller or computer. It has wheels you see that have a motor. That's how it moves.
Pretty cool.
It has sensors. It also has a GPS and light and location sensors so that it knows how to go into the room and it's not bumping into things. And then it has its tool, the UV lights.
Wow.
And that's what it uses to disinfect the hospital room. So the UV robot, Spot, our robot Spot, our Vex robot, our drone robot, they all share the same characteristics. And these are the characteristics that we're going to go over so that you can plan, so the students can plan their first design.
You mean they're going to make something?
So yes, that's why I'm so excited to be here also, is I want to give students a way to help them plan and design their own robots.
I'm so excited, Mr. Beta, because I thought you and I were just talking about all the neat things with robots and the design process and engineering the future and all the habits of mind. I almost forgot that, yeah, you wanted our friends at home to build something.
So part of building
Very
is
cool.
planning.
Yeah,
And planning sometimes takes a long time.
it does.
But planning is so important because it can help save you time. It can help save you frustration. It can help make your robot or whatever you're working on, it can make it better. And plans are very important to keep track of.
Yes.
And it's very important to write your plans down.
Yes.
And, you know, a lot of people like myself are visual learners. What that means is I like to see things. And then it makes more sense to me.
Yes.
So I'm going to help the students today. I'm going to help, and we're going to make some visual organizers.
Oh, I like that.
Have you heard of a visual organizer before?
I have heard of a visual organizer. I can't wait to see how it works with robots and all the things that we've been learning today.
So we're going to use a very specific visual organizer that's called a mind map. And it's not a map of your brain, but it sounds like it. It's more like an outline. And it's a very specific type of outline that helps you plan.
There we go.
So let's take a look. We're going to refer back to Spot.
Okay.
And we'll use Spot as an example, and then we'll use the UV robot.
Okay.
So this is where we're going to use some colors because I like to be organized. And one of the ways to organize is to use very specific colors.
There you go.
So we're going to use, let's see, I have a purple, a yellow, an orange, a red, a green, and a blue.
And it's okay if we don't have those colors, or we can color in our paper
You
that
can
way.
color in, or you
Yeah.
can choose any other 6 colors that you want to use to help you organize your thoughts. So we're going to build a map of what a robot needs to have. So do you remember some of the characteristics of the robots?
We had the sensor.
Okay, sensor. Let's find the sensor. The
okay.
sensors is the triangle.
Okay.
So if you can write sensor on that,
I will.
and we'll tape it up.
Okay.
Okay, I got tape on that. Let me help you with some of this tape so that we can get everything taped up and we could see what
Okay.
mind map
Where would you
looks
like
like.
for me to put the sensor?
So, is the sensor the main part of the robot?
It's an important part.
It's an important part.
Very important.
What would you think one of the main parts of the robot
I personally would feel that it's the body.
Right.
Because we need the body to attach all of our other stuff.
Okay.
Yeah.
So the sensors attached to the body. So maybe you should put that off on the side.
Okay.
So let's see. How about right?
We'll just have it right here till we get.
That looks very good.
So let's start
Okay.
with our body, like we said.
So we're going to use red for the body. And it's actually a circle too. And you notice that the yellow is a triangle. So these are ways that I help to organize my thoughts.
Body.
So that I know when I see a red circle that it means that's the robot body, or that's the body that we're talking about. Oh, it looks
that
so
good
good.
right there?
That
Okay.
looks so good. Okay, so we're just going to keep on adding. What are some of the other characteristics that we had?
So we mentioned sensor. We also have maybe the power source.
Power source, purple oval for power source.
Okay.
Okay, and you need some tape for that?
And then we have some tools. We have the brain.
Okay, tools are going to be a green square, and the brain is a orange diamond.
Okay. How about this? How about I get the tape, I write what it is, and then you put it on the mind
Oh, that
map.
would be excellent.
How about we do that? So
Okay.
here's tools.
Thank you.
You put tools where it goes.
Okay, so here we're going to start building our mind map. And you'll see right in the middle we have body because that's kind of how our robot's built. And then we'll put tools right over here. Okay,
Here is a sensor.
thank you, sensors. I'm going to put sensors kind of over here. And I'm going to use my black marker just to draw lines to connect
Ooh.
these things. Okay, that's how this becomes a mind map, is
So it's
that
showing how it all
these things
connects.
are connected to each other.
Here's our
because they
brain.
Okay, so here we go. Here is our brain, and that's connected to the body,
Here's some movement.
and there's the movement. And that is also connected to the body.
The
Okay.
last one is our power
The last one is
source
our power source.
and our energy. I didn't put tape on there for you though.
So remember, power usually comes
There
from
you
electricity
go.
for robots, and most robots use batteries. Some robots have other power sources, like a fuel cell, like a car running on gasoline. But most robots do use electricity or a battery to generate their power. Okay, so now this is my mind map of the characteristics of a robot. We have 6 things that a robot needs to have.
Okay.
And these are the things that we want to concentrate on when we're designing our own robot.
Okay, perfect.
Right?
That
Because
was my question.
we
yeah.
need to know that a robot needs a body and it needs to be able to move.
Mm-hmm.
And what does that look like, or how does that robot move?
So would we use this information when we're building a prototype, when we're designing? Will we refer back to this to help
So-
us put that in place?
Very much like writing, when we write an essay,
Okay.
or even when we write a story, we start with an outline, and the outline is our plan. Well, this map is kind of like a plan that has some of the details that we have to think about
Oh, okay.
when we're designing. So we could almost check them off and make sure
Well, I
that,
like that idea. Check off. That would help me.
that each one is being used when we're talking about our design.
Yes.
Okay, so let's, if we go back to our drone and we talked about the mind map, we could see that it has all the characteristics. It has the body, the white part. It has movement, the propellers that make it fly. It has tools, the GPS and the camera. It has the power, the battery that's inside that gets charged. And it has a sensor that can see. And it has the controller that acts as the brain. Okay, so what I'd like to do is if we can make another mind map really quick. Let's see. Should we just tear this
You
one
just
off?
tear it off.
Okay.
Shove it
So
right there.
the second mind map we're going to make is for spots. So if you could write spot on there, and we need to cut out some paper and
Okay.
put it just the same way that we did the last one. So I'm going to start cutting here, and
Okay.
it's going to be very simple. Just like we said, there's a green square.
Okay.
There is a blue rectangle. Okay, and remember if we, circles are hard to cut.
Oh, yeah.
Oh man, circles are hard to cut. Okay, circle is our body, the red circle is our body. I'm doing as best as I can to cut, but it's hard. It's hard to cut when you
That's
have
okay.
to. Okay, and then a diamond is usually just a square turned. So an orange diamond. Okay. And a yellow triangle. Now, I chose these colors and shapes
Okay.
to help me stay organized.
Perfect.
Because when I see yellow, I know that it means a sensor.
There we go.
When I see red, I know that it means a body, and that helps me take notes. Okay. So my oval's not too good, but we'll see what we can do.
Perfect.
Okay. So
So what am I doing with all these shapes?
we're going to put these up here just like we did for the first mind map, but we're going to put in the details of Spot.
Okay.
Okay, so if we refer back to our picture of Spot, let's look at its body.
Okay. So I love how you were being descriptive earlier when you were explaining to our friends what it looks like. So his body was dog-like.
It does look like a dog, doesn't it?
Yeah.
Or I guess another animal, maybe a cat. But it, with the name Spot, it does look like a dog. So let's call it dog-like.
Yeah.
What does that mean? But does it have a tail? No, I don't know if it has a tail, but it is dog-like.
Yeah,
So
so-
that is a description of the type of body that Spot has.
So the body would be dog-like.
So here, the body is dog-like. Okay, what else does Spot have?
Well, Spot,
Yellow sensor. Okay.
the yellow sensor has eyes.
Yes. So we need tape.
I gotcha.
Okay. We keep it going. Okay.
Keep it
so
going.
Spot
And then-
has eyes.
We
Very
can
good.
use our orange diamond for our remote.
Spot is controlled
Control.
remotely from another room.
There you go, sir.
Good. Okay, diamond up there.
And then I love how Spot had a head.
One of Spot's tools is an iPad.
Yeah.
A way for an iPad
that's the tool that it used.
to be charged and to be used while it is on Spot. It doesn't fall over and break.
Got that one for you?
Okay. And then 4 legs. That's how Spot moves. Very good. Oh, and I'm going to start connecting these two. Okay. Black marker. Okay, so the dog's body is connected to the remote control. It's connected to the sensors, connected to the movement of the legs, to the iPad, the tools, and the power source.
We need this.
Okay, we need power sources.
Yes.
Okay. So this is a mind map of how Spot works and his characteristics.
Yeah. Could you be able to hand me that mind map, the
Yes,
one that
let's look
was? So here's the mind map here, and then Mr. Abeda can explain the characteristics of Spot, and then we can kind of look and compare how we use this to fill that out.
Yeah, so as you notice, one of the things about a visual organizer is that it uses the same shapes or colors to help your ideas stay the same.
Yeah.
So the red circle represents what type of body the robot would have.
Mm-hmm.
So we put a red circle here, and inside of the circle we put dog-like.
'Cause that's the body.
That's the type of robot Spot looks like. And then remember, for sensors, it has a yellow triangle. Here's our yellow triangle. So when I start thinking about how I'm going to build a robot, I can remember that I need these very specific 6 things to make my robot. Okay? So one of the things that I've been doing is working on my engineering notebook.
Oops.
And my engineering notebook has some of these same mind maps in it. So as you see, but Miss Garcia, I'm not the best at drawing.
I'm not either.
It's hard sometimes to draw. And so it's okay in your own notes for it not to look perfect. But there needs to be some details. So here, when I look, here is the key. I have the key to my mind map. I have my colors that I drew, and I put very specific words. And I also started working on Spot. So I said, well, what does Spot have? Well, here's a body page, and I have some very specific notes under here about how Spot moves. I wrote that it looks like he's a dog, that his 4 legs move independently, and they're black, and they make him kind of look tall. I wrote that his body is mostly yellow and black, and it kind of looks like a cylinder or a body of a dog. And I also wrote that Spot has some very specific tools attached to his body. So in my engineering notebook, I'm taking very specific notes on how a robot's put together because I have a challenge for our students.
Yeah, perfect. Oh, look, you read my mind.
So
Perfect.
The reason that we've been showing and talking about robots today is I want kids to get started on thinking about creative ways to solve problems.
Yes.
What are some of the problems that exist out in our world today?
Yeah, so friends, what Mr. Abate is saying is with all this information and all this learning that we just did today, what we can do is use this information to guide us into solving some problems.
Yes.
Yeah.
I would like the students to get started on their first prototype of a robot. A prototype is the first attempt at building something, so it does not have to be perfect. A lot of times the prototype is the one that fails or is destroyed because it doesn't work.
Yeah.
But it helps you learn.
Perfect. And I love how Mr. Abeta shared with us his engineering notebook, because if you're going to look into some problems out there that we want to solve and prototypes we want to make, putting your information together in your notebook is what we want you to do. Find some problems that you see out there, find some things you might want to solve, and then put it together in your notebook, and then you can start doing what?
Well, start planning on how your prototype is going to be put together. Now, I'm not challenging you to build a full working Lego robot, but that would be very cool.
It would be very cool. And that could be a next step later, you never
Because
know.
Legos have robotic kits,
Yes.
and you could build robots with Legos.
Yes.
But what I would like you to build is your plan. Design your plan, use your notes, use visual organizers to help you share with others what it is your robot is, what it can do, and what problem your robot is solving.
Yes.
So let's talk about hero robots again.
Yes.
What do you think a good hero robot would be?
Well, I don't know. I kind of like how you have the robot you were talking about with the sensors checking for fevers before anyone went into the building, the UVs, maybe even helping guide people into certain rooms, bringing supplies in and out. There's so many different types of robots that they can think of.
We mentioned earlier that Spot and the UV robot work in hazardous locations.
Yes.
There are other robots right now that are working in hazardous locations too. Let me give you some examples.
Okay, I was going to ask you.
So there's robots right now in outer space.
You mean I can't do this?
You can't go to outer space
you need to tell
without
Mr. R that
without
because
a
he wants
spacesuit.
to go.
Robots can go to outer space, and they can do a lot of great tasks for us. We have robots on Mars.
Oh, like the rover?
A rover is a robot, and it collects data. It has sensors.
Nice.
It has movements. It has a brain. We have robots flying towards the sun. We have robots underwater. Wow. Now, humans can't breathe underwater.
No, we can't.
But a robot does not need to breathe. So these are some other places that might be hazardous that robots today are going to and completing tasks and helping humans.
Oh, I love that. Oh, I love that.
So what I like the students to do is think about some of the problems that we have in the world today, very much like problems that we would have in hospitals, or maybe we mentioned firefighters, or even law enforcement, the military, healthcare workers, industry like engineers.
Yeah.
There's ways to use robots, and there's so many problems to solve, but we have to be creative. Yeah. And being creative is one of the parts of the design process that is so important.
I was just going to jump into that.
Our mind map and our engineering notebook help us record our ideas.
Yes.
Because when you're creative, sometimes you forget about the idea that you had yesterday about the robot walking, or maybe you forgot about what color you want the body to be. So if you take good notes and you make graphic organizers, these are excellent ways to share your ideas with others.
Perfect. And I'd love to bounce off of you really quick. So like Mr. Abeta said, you use your notebook and he's giving you a challenge. He wants you to come up with these robots and he wants you to design and just draw out and maybe investigate. But then don't forget when you're doing that to think about our steps. We have asked some questions. How is it a hazardous job?
Research.
Yeah. You have to use your imagination. Make sure you're thinking like, how can I make this work? How can I make it better? Make sure you have your journal or any paper. Make sure you're planning. And then you're going to think about, okay, in the future, I'm going to create something like with your prototype. And then when you're done, you're going to share it. You could take pictures, send it to your teachers. You're going to send it maybe to aps.distancelearning@gmail.com. You could also send it to at APS ETF to share it so that we can see those. You can share it with our at home with APS. And then make sure there's also ways to improve too after you've done the design process.
What I'd really love to see is drawings of prototypes.
Yeah.
That is probably one of the strongest ways that you could help plan what you're going to build.
Yeah.
And like I mentioned, when you draw, it does not have to be perfect, but sometimes it needs very specific notes that you put by it that help others understand. So if you get done with your graphic organizer, your mind map that has the characteristics of your robot, you should share it with people. That's one of the ways that we get better, is sharing our ideas with others. Most robots are built by teams of people who collaborate and help each other understand.
So could you and I work together? Maybe
That would be so
bounce
fun.
ideas off of each other,
Yes.
and then we can create and build something together. Like we can collaborate
That would be excellent.
together. Yeah.
So some ideas for building at home when you're designing your prototype would be just materials that you could find.
Anything you could find around the
So,
house.
we just have materials that we could cut up and that we could use, and some of these looks like parts of robots already, right? So we have just things that you find around the house. Those can be built, cut, glued together, taped to make a robot. Another thing that we very much like to do is also play with Legos. And Legos have very many combinations and ways to make a prototype.
Yeah.
And this is probably something most students will have a very fun time with, is really figuring out a way to build a sensor, to explain to their friends how it gets power,
Yeah.
to what problem the robot that they're building might solve, and how that could help other people. So play is a part of design.
I was just going to say that.
It's so important to play when you're being creative.
And guess what? You could turn it into a family project. You could turn it into, maybe a set of people at home build something and then the next person adds onto it or improves it, or everybody all together, or you challenge each other. And another example, I found this in the teacher recycle area. So this must be from something that another teacher made earlier. But
a build.
Yeah, I could use this and maybe take things off or add to it and see if maybe this would work with a prototype that I drew or made or put together. I don't know yet because I haven't gone through the steps of creating. I don't have my mind map yet. But I saw this, so this could be possibly be something I could use.
I do like the way it looks,
Yeah.
and it has some of the characteristics of a build for a robot.
Yeah.
It has some power, right? And it has a body, and it has a tool.
It has tools, yeah.
Well, how can we build a brain onto that and some sensors, and then we would be talking about one of our first robots.
I know, I would have loved that. And another thing that our friends at home could do is maybe after they've put their journal together and they have their design drawn and they've shared it with someone and then they've improved it and they've shared it with us, and then maybe the next step they've done the build. Maybe another thing you could do at home is maybe write about it.
Writing is a very, very good way to make sure that the details of your ideas are covered. And another aspect of the design process that's so important is when we share, to get feedback from others. It is so important to listen to the ideas that other people have to say about your ideas and to not take it so personally.
Oh, yeah.
A lot of times when somebody tells you, oh, maybe you should change the way that the legs move, it doesn't mean that it's a bad design. It just means it's something to think about. Maybe it will work for your robot and maybe it won't. But we're always trying to make things work and make them work better.
Oh, I love that. And I love how he said that. When someone tells me how to improve something, it did take a little bit for me not to go, why don't you like my idea? But you're just helping me make things better. And so that works.
We are just
great.
in the preliminary stage of our idea because we are trying to organize our thoughts, take very specific notes, and keep track of details.
Yeah. So friends, let's just review real quick. We had our vocabulary words. We had our design process. We're making prototypes. I hope you listened to some of the things that we said. I'm so excited that I got to come visit with you and learn from you. We got to learn about the design process, engineering the future. Mr. Obeda, I'm so happy I got to be here with you today. Make sure that you think about the habits of mind. Friends, Mr. Obeda, I'm so happy. Thank you so much for joining us with At Home with APS.
Thank you.